Hey guys. Oh my gosh. I'm so sorry for the Zoom bomb. Can you hear me?
Yeah.
Oh my God. I'm still shook up. I thought it was like maybe one of you guys or maybe my kid got on. Ugh.
Did you
There's
get
some
it figured out?
there's some scumbags in the world. Yeah, did you guys have to log in with the password? Did that work all right?
Yeah, it worked fine.
Okay. So Isabella, you're shaking your head. Was there no request for the password when you logged in?
Yeah, there was no request. I just clicked the link and it let me in.
Oh, okay. All right.
Yeah, I didn't have to use a password either.
Oh boy. Well, one of the things that was a thought, oh boy, so weird. This could go poor again.
Maybe
You're
because we
allowed to
logged in through the
people out
link.
though. Like
Maybe
you're allowed to remove people.
what was
If
that?
I think you're allowed to remove people. Like if there's somebody that you don't recognize their name or whatever, I think you're
Yeah.
allowed to kick them out.
Okay. Yeah, I called IT immediately and they shared the screen with me and got in and put the password protection thing on there. So I don't know, maybe, yeah, again, I'm sorry, and I'm still kind of shook up about it. Also, I think there might have been an issue with the quiz. I'll go in and on the question that you guys might have flagged, I'll go in and hand calculate those. I'm still learning the setup, and I apologize if there are any troubles. If you ever run into trouble with the quiz, you just put that little flag on there and shoot me a message afterwards. I can always go in and hand grade stuff. So not to worry there. It was just a minor one part of a question seems to be a bit off. So again, we're all still learning. Hopefully this is going to go okay. I don't have as many people as I'd like right now. So maybe we'll wait a little
I
bit.
made a Quizlet to study for the quiz,
Yeah.
and then Quizlet just shut down on me. So now I
Oh,
can't
no.
use
That's
all the
weird.
work I put into it.
Oh, I'm sorry about that. I've never heard of Quizlet before, that term.
Oh, it's like a website where you can just make flashcards
Huh.
and you can quiz yourself on this stuff.
Oh, cool. Cool. Very savvy of you. All right. Yeah. What, seriously, don't people have better things to do with their life than just mess with ours that way? Sophia, this is 2 times now. I'm so sorry. You kind of gave me that warning that I should be cautious, but I thought just because we were set and doing it out of Moodle that we at least had some, you guys have to log into Moodle sometimes to deal with that.
Yeah, I don't know why it happens.
Oh, it's awful.
I think someone just like gives out the meeting ID, someone in the class. 'Cause I don't know if they can join without it.
Huh. Well, hopefully that's not happening. You guys know how much I'm stressed already. Try not to do that. Anyways. Well, my plan is, for whatever reason this password thing didn't actually activate, is that when you go into our class or our lab, at the top is where I've been posting the links to the Zoom meetings. And then right above that, I'm going to put the password protection. So, when you go in, if you're not going to just click on it off of the email, you can go in and you can click it off of that, the link in Moodle, whatever lab or class that we're in, and then the password will be right there. So again, sorry about that. At least it wasn't something totally graphic and it was more funny in retrospect. Oh, anyway, all right. Well, I'm gonna keep track of these names. Hey, Devin. Yeah, I should have known. There was one name on there that I was uncertain of. And oh, now I'm seeing. Thank you, Hadar. I'm actually clicking on thumbnails, looking to the right, and you can remove somebody from there. So I know someone had done had put themselves on as like a code name Dr. Worm at some point. So if we can just kind of keep our names as what our names are, so I can remove the unwanted jerks.
Yeah, I'll just be Danny from now on.
All right. Or Hot Dog Man. All right. That's good.
Yeah.
I figured it was somebody else because Dave Francie had that same person in class, and he thought he was being Zoom bombed, and I'm like, no, I think it's just one of our students being funny. But now we know for sure it was Danny.
No, it's just Danny.
Okay. All right. Well, again, I'm going to try and be as short and sweet as I possibly can for you guys and make this as painless as possible, given our constraints. So I am going to share screen over to our Moodle page and kind of just show you guys. Can you see our Moodle site? Okay. All right.
Yeah.
So we are down in the forest community section, which is below the cemetery demography. I've got a bunch of little articles on here, PDF articles that talk about abiotic factors and how it influences forest communities, you know, moisture gradients, light conditions and herbivory, land use history, which we know is very Gleasonian, right? Organic matter and soil shading, deer impacts on saplings, so that would be a biotic factor. So you're kind of getting the trend, this idea that there's both biotic and abiotic factors that can influence you know, forest communities. And the last two that I want to draw your eye to are Silvix Volume 1 and Volume 2. And when we click on it, and I think I've downloaded this twice, they used to be hyperlinks. Think of them as field guides for our trees, okay? So I don't actually need to do that. I have them right here. So Silvix Volume 1 and Silvix Volume 2 will be organized with a table of contents that is the species of tree that we're looking for. So it's just, they're big files, so they're just taking a while to open. And when we go to that main front page of whatever one decides to open first, you can hyperlink to the name of the species. So Thuja occidentalis is going to be our northern white cedar. Pinus strobus would be our white pine. Okay, so we've got our Atlantic white cedar. We're looking for northern white cedar. And we've got pines. Let's do one of the pines that we had. We had Eastern white pine. Okay, so I've just clicked on Eastern white pine, and when we do our graphs today, you'll be noticing that some of the sites, you know, the Xeric and the Mesic site, white pine was very common, and I think you saw from the visuals that white pine is a very big tree. It's a dominant tree in the system. Size-wise, they're usually very, like, you walk in and they feel sequoia-ish in our forests, right? They're big bowls of their trunk, and they've got the whorls of branches above. And they were harvested way back when for ship masts for the Royal Navy during like war times. But anyway, the white pine, which is just one I randomly picked, and you can go in, and the Silvix book is arranged. So Silvix 1 is softwoods, which are the evergreen conifer type trees. And so you can look, and it shows you the range of the white pine. It tells you the climate needs, so temperatures. It tells you the soil type and topography. So it'll mention that it needs, spodosols, altisols, and septisols. Some of them we're familiar with. It talks about growing ideally on nearly all the soils in its range. It's very good at competing in well-drained, sandy soils of low to medium site quality. So think about our soil types. You know, we talked about, you know, grabbing some soil, adding water, and kind of trying to roll it in your hand to see if it's sand or silt. And if you ever have been out to Ruger Woods, one area might seem more sandy than another. So it talks about, you know, soil types. It's going to mention pH, I think, a little later on right here, right? And it's going to probably talk about light levels, what other species it's usually found with, and so on. So when we go through, and I'm thinking forward to the assignment, when we go through and we make our graphs together today, we're going to have graphs that represent the density of certain tree species at this site versus that site, the dominance, which is the area, the size of the tree at that site, and then the frequency, how often all 4 of the plots that each group made, how often that tree showed up in them. That kind of speaks to the distribution of that tree in the forest patch. So you might, you might find out that white pine is a dense, shows up as being the highest density tree in the mesic site. Well, why is it not the densest tree in the xeric site? You can go to Silvix and you can see some of its abiotic needs, maybe some biotic needs, and that might help explain it, okay? You might also, as you're looking at the graphs of density, dominance, and frequency, you might look and say, oh, well, how come we have this one rare species that we only see in the dry site? What's unique about that? And so you might pull up Silvix 2 and look and see hop hornbeam. Why do I only see hop hornbeam in that dry site? And you read through its characteristics and it says it needs rocky, cobbly soil, it needs higher light levels, that sort of thing. So again, as you're trying to piece together why our trends look the way they do in the graphs, looking to Silvix on some of the very dominant species, very dense species, or the rare ones might help explain why the communities look the way that they do. Okay, so I just wanted to draw your attention to those as we begin. Okay, I'm just going to do a quick glance at our friends. Okay, I think we've got everybody that is in our group. Okay, so Silvix, just so you know, they are available there for you in the Moodle site, Silvix 1 and 2 right here. Last week when we met, we took Mary Aldred's virtual tour of what we would have done to collect our soil, to look at our light level with the densiometer, and to ID the trees in that 10-meter square plot. And I gave you that little video that talked about our common trees that would be found in the woods, and then of course the kids going through how to use a dichotomous key. Well, today we are going to scroll down to the forest community raw data. I'm going to open that up in a sec to show you, and there's an associated Word document, very brief, 7 questions that I've pulled in some of the graphs that we will make today together for you to kind of answer those questions. But what we're going to be doing today is evaluating density, dominance, and frequency, summing that stuff all together to get a value of importance of certain tree species in both the mesic and the xeric sites. We really want to see, are these communities different? And so you can imagine that we could certainly do like a Shannon-Weiner or a Simpson calculation of diversity. We could look at evenness. We certainly can look at species richness. That's definitely something we want to do. And we should be able to evaluate, we could do Sorensen type stuff too, okay, because we're doing beta diversity. So we'd be comparing between mesic and xeric sites, all right? And so what I want us to do is, hold on a sec. Just trying to scoot some stuff around. Okay, if you guys can call your attention to this PowerPoint that I have up here. I'm just going to go through this real quick as an overview of what we're going to be working on today. Okay, can you guys all see that? Yeah? Somebody unmute and let me know.
Yes.
Yeah. good.
Okay, thank you. So we walked through Ruger. This is a student group last year, kind of moseying through towards the back, towards that dry site, the xeric site. The purpose of our lab is going to be to evaluate the community composition in these 2 forest stands, the mesic and the xeric. Mesic being moist or wet, and the xeric being the dry site, okay? And we're going to be looking at relative density, relative dominance, relative frequency, and importance. So density is the number of that particular species divided by area. Dominance brings in the diameter that you guys took, so the size of that particular tree that you measured, and sums it up across the species. So you get a sense of how large of a space the white pine takes up compared to, say, the northern white cedar. And then the relative frequency, as I mentioned, is going to say, okay, well, we had 4 groups. They each had 10-meter square plots. Did we see white pine in each of everyone's plots? And if so, then the frequency would be 4 out of 4. If we only saw it in 3, the frequency would be 3 out of 4. Okay, so we're getting a sense of sort of the distribution of that particular tree species. And then importance is just a quick sum, you know, like I want to know how important, well, importance is going to take into account density, dominance, and frequency. So that's kind of an easy one to immediately right off the bat say, yeah, I think in this site, that's the most important tree, and the other site, the other one is the most important tree. And again, then we're going to step back and we're going to say, are these the same communities? Do we have the same species in each? If not, are the patterns different? Are some rare, some most dominant? And think about the abiotic factors that we evaluated. So remember, we used a soil core, we looked at soil pH with the soil pH meter, made a slurry, added water, and then stuck the probe in there. And then in terms of our moisture, we got a sample, we dried it down in the drying oven and got a wet weight, dry weight, and subtracted them and kind of got a sense of percent moisture in each of the soil types. We grabbed soil, we added water to it, rolled it in our hands to look at soil texture. Is it more loamy, silty, or sandy? And then I did mention that we would look at a densiometer, right, that disco ball thing, or our fisheye on the top of our canopy to see how much was open versus closed canopy. That gives you a sense of light needs for certain, you know, species. And then we talked about biotic factors, right? Woodpeckers, forest disease, browsing animals like deer and cottontail rabbits and stuff. So moving on to our first calculation that we'll be doing today, it's density. And to call your attention, if you're following along in the lab manual, page 64 would be where you would want to look, okay? Page 64 has the calculations sort of written out for you, and it speaks firstly of density, but this is a nice visual of that. So your density is the number of that particular species that are found within your given sample area. So we sampled a 10-meter square plot, and we want to know how many white pine we have. Say we counted 4 of them, it would be 4 divided by that 10-meter square area, okay? If we looked at maybe ash trees and there were only 2, it would be 2 divided by that particular area. So density is a very straightforward value. It's just take the number of individuals of that species and divide it by the area that you surveyed. So as you can see here, the blue one is going to probably have greater density than the red species or the pinkish species, okay? And you can report it as a percent, you can report it otherwise as a number with decimal continuous value. But when we go and type in the formula into the cell, we're going to be using the count if, okay? So we're basically going to do equals count if, open parentheses, and we're going to highlight the whole column that has the species names. And we're going to put a comma right after that range selection. And we'll click on the name of the species that we want to count. So we'll click on the pine straw, or we'll click on the thu ox right after we've told it what range we want to grab. Okay, so that's how we would do the calculation for relative density. And we can sum up the individuals with our equal sum, and we can divide it by the area. We're going to convert it to hectares. So there's 4 plots of 10 meters squared, and when we get those all summed together and convert it to hectares, we're going to be dividing by 0.04 hectares across the board. Okay, and then if we want to get a relative value of that, we're going to take our density that we just calculated and divide it by the area. And we're going to divide it by the total of all the densities across all the species. And notice there's dollar signs around that because we want to keep that always as the denominator. And then we're going to make that a percentage by multiplying it by 100. Again, all of this will be more clear as we go through the Excel sheet together, okay? Very important that any of the relative density rows should, or relative anything, relative dominance, relative frequency, should always add up to 100%, okay? If it doesn't, then we screwed something up. Now we move on from density, again, numbers divided by area for each species. Now we're gonna look at dominance. Dominance we've talked about in class already, but that's like the most, takes up the most space, right? It's the most dominant. It dominates in that area. It's probably extremely competitive. I've given Sequoia as an example, but our DBH, so that diameter at breast height that we took with that diameter tape measurer, will give us this value. So we have to do a quick conversion. That diameter tape is going to report back to us a diameter. We're going to calculate via a radius, right? This diameter of a tree is a circle, right? So we're looking pi r squared to get at that radius value. So we're going to just make a slight adjustment on our basal area calculation and be able to calculate dominance. So we do this easy calculation that again takes into account pi r squared, and we will sum it up for each of the species. So we'll sum up the basal area for each of those species and get a sense of just how giant, right, or how big of a space that particular species takes up in that community. And that is what dominance is. It's the size, the area, not just the numbers of them, but the size of them in that area. You can see obviously the pink one would be the one with the greatest dominance. And so for basal area, as I mentioned, we're going to take our diameter value that we gathered and we're going to square it. Remember, pi r squared. We're going to multiply that by this crazy value right here, because that takes into account pi, okay? And that's the calculation kind of broken out is in our lab manual, but for the purposes of our Excel assignment, you just need to know that we need to take our area that you measured with the meter diameter tape and square it, and then multiply it by that long decimal, okay? And again, we need to sum up each of those basal areas for each individual tree, but we want to sum them up specifically for that particular species. So we'll sum it across, you know, for the white pines, we'll sum up all the basal areas squared of the white pines, and so on and so forth. To get total dominance, we'll sum all the way across the species. To get relative dominance, we take the dominance of one species divided by the total dominance of the sum of all of those species, and then we multiply that by 100 to get to a percent. Again, all of that will be more clear when we do our calculations. And then frequency, as I mentioned, how often do we see it across all 4 of our plots? You guys, this would have been group 1, group 2, group 3, group 4. You would have gone out and surveyed, you know, counting up how many of each individual species you got, and then getting the measures of diameter on them. But how often do we see the red one or the pink one? Do we see it in each of our plots? In this case, we do. So that would be 4 out of 4 for the frequency of that red species. And then for the blue ones, we see it in, whoops, not in this one. So it would be 3 out of 4, 0.75 for that frequency, okay? Again, to do relative frequency, we take the frequency of that species divided by the sum of all the frequencies, and then multiply that by 100. Relative gives us a proportion out of that 100. Okay, and that's just kind of what I've broken down here. Again, all the relative values have to sum up to 100 to make sure we're right. And then finally, importance, that, like, you know, kind of like species richness. It gives us a feel of diversity at a quick glance, and it accounts for density, dominance, and frequency. So basically, we're going to take our relative density, relative dominance, relative frequency, we're going to sum them together for that species, and we're going to divide it by 300, because we usually think of importance on a scale of 0 to 1, okay? And so you can see here, we'll sum them up, and we will divide by 300. Okay, and we're going to have a tab that's going to allow us to paste those relative dominance, relative frequency, and importance values that we've just calculated into one grand table here. And we'll probably have to maybe use, remember, paste special values transpose. So they might be arranged vertically in one, and you need to paste it horizontally. We'll use that calculation, that step. And we'll be able to compare those sites, okay? And so that is the plan. We're gonna look also at a tab that we have in this assignment for abiotic and biotic factors, okay? So the abiotic one is basically soil pH and soil moisture across those sites that were surveyed. I've got some values in there again from last year. And then you guys can either, we're going to do it together, but we can open up, remember we did the physics t-test, we Googled that and we were able to paste the values in directly and hit go at the bottom, and it gave us a p-value and a degree of freedom and a t statistic. We can do it directly in Excel. There's a function called equals t-test, and then you basically highlight column 1 that you want to compare, a comma, highlight column 2 to compare, put a comma, and then hit 2 because you're going to do a two-tailed t-test, and a comma, and then 2 again for equal variances. You assume these are equal variances if the numbers are kind of similar. Unequal variances would be if the numbers were like way crazy, wild, or you had uneven numbers of pHs, like you didn't do a pH at one site, but you did, you know, you did 3 in one site and you did 17 in another site. Then you would look to do the unequal variance, and you can make an adjustment there. We actually have a built-in Excel module, a statistical module in our Moodle site up by the statistics section, which I think is going to be nicer for us to use because it's going to actually do the graphing for us and give us the error bars, so it'll save us time. Okay? So you'll be just doing a comparison and making a graph. Is the pH of the soil different? Is the soil moisture different across those 2 sites? You'll look at your results of your t-test. You'll see the p-value. And remember what our cutoff was. You guys remember? What was our cutoff? You guys remember the cutoff? I think we just had somebody jumping in on us, so I just removed them. Hopefully it wasn't a friend of ours with using their dad's Skype or something. So it was 0.05, right? 0.05 is going to be our cutoff. And so we'll kind of make these beautiful graphs. We'll do our t-test and we'll see, yeah, you know, if we get something statistically significant, oh my goodness, it's happening again. Then that's something that we need to address. Okay, so let's start our calculations. Clearly, IT did not help me. I don't know. I think you should be able to open the Excel in Google Sheets. And again, it's going to be done for you. So should be good to go. Okay. So again, I'm going to kind of Julia Child this, get as far as we can today. All right. I don't know if Kayla, are you on with us? She's our TA, right? I don't know who iPad is. This is going to be a pain in the butt, you guys. I don't know why we're being targeted. Anyways, I want you to go on. You can access the raw data here, and underneath it, I'm going to reveal the answer key shortly after we've kind of worked through some of this stuff together. So this is what your data sheet should look like, okay? And hopefully you guys can see that. I've got a MESIC tab, a Xeric tab, a comparison tab. I've got our abiotics right here and a tab for biotics, okay? Looking at woodpecker, deer pellets, forest disease, indicator species, okay? So let's go over here to our MESIC site. And in the MESIC site, you'll notice these are the groups. We have groups 1 through 4. These are our species. So we've got Thu-Ox, which is our cedar, pine straw is our white pine, and so on. And then the diameter measurements that you guys evaluated. I've got our calculations right here, and I've got our summary tables right here. Okay, so I want us to just walk through this together. Hopefully you guys can follow along. The first thing we're going to need to do is we're going to need to calculate our basal area. Oh my goodness. This is a pain in the butt. I don't even know what more I need to do here. I'm going to just keep working, guys. And if things go south, I'm going to shut this down and I'll just do our lab remotely and talk to IT about why we're targeted. Okay, so basal area, that is that weird calculation where we take our DBH. So notice what I'm doing over here on the screen. I'll try and make it a little bigger for you guys.
Is there an option that says disable booted users from rejoining or something like that?
I don't know. Is that Danny?
Yeah, that's Danny. I Googled it.
You tech savvy here?
Sorta. I mean, I just Googled
Yeah.
how to stop people. from-
Disable participant annotation. I don't know that I manage participants.
I mean, is it possible that it is
Oh,
actually?
can I lock the meeting?
Maybe, yeah, but that would all that might prevent people who are late from our class from joining. I mean, it's already 1:30, so I guess.
Yeah, okay. Maybe I'll try that. Hopefully I haven't screwed anything up. Let me try locking the meeting. Are you guys all still there?
Yep.
Okay.
Still here.
My panic maybe is much reduced at this point. I hope I'm not, keeping anybody else out, but, screw that. I don't want us to get bombed again. It's very, very upsetting. So we're all still here? We're all in?
Yeah.
Okay, thank you. Okay. All right. So our first thing that we're going to do is we're going to calculate our basal area calculation. So it's equals, and we're going to click on that diameter that you measured with the diameter tape. We're going to square it. So I've got a caret 2, and then I'm going to multiply it by that crazy long decimal, which again comes from that pi r squared. It's 0.00, 0.0000, 4 zeros, 7854. Okay, and because that calculation is going to continue all the way down the line, I'm just going to grab that corner and double click it, and it's going to calculate that basal area squared for us all the way down. Okay, now I'm just going to add in, I'm going to insert a little space here just for my own needing to see it and being kind of anal retentive that way. All right, so we're going to go over here to number of individuals, all right? And if you remember back from that PowerPoint, we need to count up how many thuocs we have in this particular table, okay? So what I'm going to do is I'm going to use that count if calculation. So equals count if, open parenthesis, and I'm going to grab the column that has all of our species. Okay, and I basically just said, all right, do a count if function in this column, but I'm going to put a comma here and tell them what species I want to count. Well, I'm just going to click on any thuocs because that was my first one. It's telling it to count all the thuoxes that are in that column and then hit enter. And so I just got 29. So like magic, I didn't have to actually go down and count all of that. Okay, now I'm going to do equals count if again. I will grab that whole column and put a comma and click on a pine straw because pine straw was the second one. Okay, everybody with me on that? Okay, now pine rig equals count if, and I'm going to highlight all these, comma, and click on a pine rig, and now I'm going to do this sugar maple of some kind equals count if. Grab that, comma, and find it. And then one more equals count if, the pine res, comma. Okay. Alrighty, everybody good with that? What you just did was you did an N calculation. You got to count the number of individuals of each of those species. And now I'm going to sum that up, and I'm going to get a total equals sum. And I'm going to grab what I want to sum, so I'm highlighting this. And I can actually calculate that all the way down. Just drag that down. And right now there's nothing in there, so it's not, but it will autofill later, okay? Now density, remember density is the number n of that species divided by your area. So what I'm going to do is I'm going to do equals, click on my n above, divide, and click on the cell I have up here for my area. And remember, that area is the same across the board. So I can hit F4 to make the denominator always stay at that 0.04, okay? And I'm going to drag that across. And then for relative density is the proportion of the density of that species divided by the total density times 100, okay? And remember, this is the one where the cell should always in the total add up to 100, okay? So I'm doing equals, clicking on my density, dividing, clicking on my total density, and I'm going to hit F4 because that's always how it'll be across the board, just the numerator should shift. And then I'm going to multiply it by 100 and drag it across. And thankfully, it adds up to 100. Okay, do you see how I did that? We got our total individuals with the equals count if. We got our density, which is that number above, the number of individuals divided by our area. Our relative density is just the density of that species divided by the total density times 100, okay? All right, so now we're gonna move on to our dominance, and the dominance calculation takes into account that weird basal area calculation we just did, okay? And for this, we need to sum up the basal areas for that particular species, okay? And so for the dominance of Thu ox, I'm going to start by doing equals sum, open parentheses, and I'm going to sum up the basal areas that are associated with the green Thu oxes. So I'm hitting my control so that I can grab multiple groupings as I move down my column. Okay, so you'll notice that it has summed up, you know, certain regions because they were found in different groups, different plots, and I get this dominance value. Okay, I'll do the same for the pine, the white pine, equals sum, and I'm going to go to the basal areas of the white pines. I'm going to use my control button as I go down the line here so I can grab those multiple groupings. Okay, and again, that is giving us the area that's encompassed in those plots by the size of the white pine. Now I'll do it for the pine rig, equals the sum. Okay, grabbing the pine rig ones. Okay, and the ace pen, there was only one of those, so I can just do equals and click on it. And the pine res, I think there might have just been one pine res too, so I can do the same. Okay. And for relative dominance, remember relative dominance is equals, click on your dominance, divide, click on your total dominance, put the dollar signs around it because that always stays the same, and multiply it by 100. So equals, click on the dominance, divide, click on your total dominance, put your F4 on it so that it stays always that way, and multiply it by 100. And I can drag that all the way across, and everything adds up to 100. Okay, so dominance again, the size or the area that tree encompasses. Now frequency is a different story, and I've kind of made a little area down here for our frequency. Okay, these are the groups, 4 groups of you guys, and you went out and you surveyed, and group 1 picked a site that had like 4 different species. So did group 3. And group 2 and 4 only had 2 different species. But we want to look across the board. How frequently do we see that particular species crop up? So in terms of the frequency of Thu ox, and I'm just for the purposes of you guys understanding it, I mean, you'll know how to do this calculation easy, but I'm going to go through the calculation. So we've got 4 groups. Thu ox is shown 4 times. So it's 4 out of 4. Or 1, okay? For pine straw, same deal, right? We see each group saw pine, white pine in their plot, so that's 4 out of 4, equals 4 out of 4, okay? For pine rig, we see it twice, so that's 2 out of 4. For the ace pen, that's 1 out of 4. And the same is true for the pine res, equals 1 out of 4. Only one group saw that. So in terms of distribution, you probably already have a sense that your cedar and your white pine are distributed more, evenly across, and you may have fewer of those other species because they're not showing up as frequently. Now remember, the relative calculation is simply equals, click on your frequency, divide it by your total frequency, hit your F4 because it'll always be that, and multiply it by 100. And then you can drag it across. Okay, and now importance is simply adding your relative density, dominance, frequency, and dividing it by 300 because we want it on a scale of 0 to 1. Okay, equals, click on the relative density. I'm sorry, I'm going to do equals sum. Click on the relative density, dominance, and frequency. End your parenthesis, divide by 300. Okay, and then I can drag that across, and bam, it equals 1. Okay, so what we have just done is a complete evaluation of density, dominance, and frequency, as well as importance of these particular tree species in the Mesic wet site. Okay, and my summary table is right here, and so I want to basically just do that paste special values transpose. So I need my relative density to be vertical. Well, right now relative density is horizontal. So I'm going to highlight it. I'm going to do Control C, and I'm going to click where I want to paste it, go right click, paste special, values, and transpose. Okay, same with the dominance, the relative dominance. Control C it, right click, paste special, values, and transpose. Okay, and for frequency, same dealio, copy that, right click, paste special, values, transpose. And for the importance, right below, same thing, right click, paste special, values, and transpose. Now I know you guys had asked if this is all going to work in Google Sheets, and I believe yes, that shouldn't be a problem. There may be some limitations to some of the formula stuff. I don't work in Google Sheets all that often. Graphing might look a little different, but I think also I've sent out some emails that you guys have Microsoft Office free through school. I don't know if there's any limitations to the type of computer you're working on right now, but you can go back to the emails I sent and there should be some links as to how to access that if you needed to, okay? For our purposes, you should be fine. You know, like I said, I'm gonna give you the answer key when we're done, okay? Any questions on the calculations at this Mesic site? We're good?
How does the first part where you like count if, how does that work again?
Sure, yeah, I'll go back and give you a quick review. So let me get rid of this, okay? Count if is gonna basically ask you for two things. It's gonna ask you for where am I gonna be looking to count? So it needs you to highlight the column, and then it needs a comma, and you click on the word that it's seeking out to count from that column. Okay,
Oh,
so
okay.
for thuox, it's really cool, right? For thuox, it's equals count if, open parenthesis, and then you highlight your species column because that's what you want to count. You want to count how many are of that word, right? And instead of just hitting enter, you have to tell it what you want to count from that column. So you do comma, and then you click on one representative word that's the thuox, and you hit enter. And it gives you the value back. It counted it for you from that particular column. Good?
Danielle,
Yes.
can you open the room up because Jason is trying to come in?
Oh, yeah. Sorry. I don't know. Can I open the room up? I'm scared. Hold on. Okay. All right, tell him to join quick. I'm going to lock him back out. While we're waiting, anybody else have any issues? Everything seem okay?
Is the density, is that just counting up how many of each species
Yep.
there are?
Yep, it's an equals count. Yep, I still don't see them.
And are these names like the scientific names?
John. Is he John? Oh no. I don't trust that he's John. So Jason's just gonna have to listen later. I'm really anxious.
What was the formula for the dominance again?
So the formula for the dominance, just so you, in case, you know, you don't jot it down right now, on page 64, it's listed right here. So it's basically the DBH that you calculated. So the column of DBH equals, click on your DBH, caret 2 to square it, and then multiply that by 0.0000, so 4 zeros, 7854. Okay, and how that's derived is on page 64 of the lab manual. Okay, it takes into account the area of the circle. All right, if somebody can reach out to Jason and ask him if he truly was John. If not, just
That
tell
was
him.
him.
What? That was that?
That was, yeah.
I
It was
was
him?
John.
Yeah,
It's
that was
alright.
him.
Oh, are you on now?
Yes, love you.
Wait, is he on?
No, he's not here.
Oh. All right. All right, try it. Tell him to try it again. Sorry, I'm just trying to be extra cautious. Any other questions while we're waiting?
For this stuff.
He told me he can't join again because the host kicked him out, but he said he's just gonna look on Moodle for this.
Okay. All right. I'm sorry, you guys. I just, you know, this is a scary time. So hopefully we are locked. All right. So sorry, Jason. I don't know if you're on somebody's cell phone right now, but everything you need will be on video. And for everybody else, I hope you understand why I'm being paranoid. Things could get worse than the penis that we saw being drawn the last time. Okay, so any questions on the calculations we did here? All right, we're gonna move on to xeric. Xeric looks a little different, right? There's a lot more color here. We have a lot more species to contend with. So again, just in review, number of individuals equals count if, okay? And we're gonna count if what? We're gonna go down and highlight that whole column, hit comma, and then go up and recognize that it's the pop gra we want and get a count. And for Prusair, we'll do the same. Count if, grab that column, comma, click on a Prusair. Okay, I'm just gonna proceed so you guys can kind of see the rhythm of it. That one was easy, just one. Almost. Okay, so we've just done our counts across those species, and now we want to sum up how many total individual trees we had in that plot, in all of our 4 plots. We had 45 total trees that we evaluated. So now we need density. Okay, density is those number of individuals divided by the area, and we're going to hit F4 because it'll always be that. Drag that across. Okay, remember this sum, we can drag that all the way down. It's going to auto calculate for us. Okay, now relative density is the proportion of the density divided by the total density times 100. So equals, click on your density, divide, click on your total density, hit F4 because that's what we always will divide by, and then multiply it by 100, and we will drag it across. Okay, and dominance is the sum of those basal areas, which we haven't calculated yet. We did that first last time. Let's do it now. Equals, click on your diameter measurement there, caret 2, and then multiply that by that crazy long number, 4 zeros, 7, 8, 5, 4. Okay, and then we're going to double click it or drag it down so it'll autofill for us. And so your dominance is just summing up those basal area squared calculations for each of those specific species. So we'll do equals sum, and now we need to sum up the pop gras. Okay, so I'm using my control function and working my way down here. Looks like it's only that one area that's got that. Okay, proofs there. I'm going to sum this, and then I see it again here. And here, I'm going to look for the blues here. See if I see it anywhere. Just that location. Oh, right there. One more I almost forgot. Almost. This is the cumbersome part. Just one on that one. And Fra-Am had quite a few in this site. I think we might just have one. Oh, no, we have 2 or 3 of these ace rub ones. Almost. Just one on that one. And these were all towards the bottom in our last group. Okay. All right. So our total of dominance is 3.76. Okay. And we're going to go and look at the relative values of dominance now. So what we've just done is summed up the basal area calculations for each of those species. And now we're going to look at how that relates to the proportion of the total. So click on equals, click on your dominance for pop gras and divide it by your total dominance for all of our sites. You're going to hit F4 and you're going to multiply that by 100, okay? Because we're always going to be dividing by that total dominance. We're going to drag that across, and that should equal 100. Excellent. Okay, so now we're on frequency, how often we see it showing up, that species showing up in each of our plots. The first one is pop gras, and when we look over in our frequency area, I only see it showing up once in one of our sites. So that is equals 1 divided by 4. And over here, Prue Serre, we see that twice. So that one was 0.5, right? Or 2 divided by 4. And for this one, we've got equals your 2 divided by 4 again. For this one, we see 3 out of 4. On that one, we've got 1 out of 4. On this one, we have 2 out of 4. Here we have 1 out of 4 groups that saw that tree. Pine straw also looks like a 1 out of 4. Ace rub is 2 out of 4. Pine res is 1 out of 4. And this last one is only one site or one plot that had that, okay? So our total of the frequencies of all of that is 4.25. That's important for the relative frequency, which is just equals, click on your frequency, divide by, click on your total frequency, hit your F4, because you're always going to divide by that, and multiply it by 100, and drag that all the way across. And then your importance, remember, is the sum of all 3 of those relative values and divide by 300. So equals sum, and I'm going to control click on the relative ones for the Pop Gras, end my parentheses and divide it by 300. Again, wanting this to be on a scale, and I'm dragging it across, a scale of 0 to 1, and the sum should be 1, okay? So you'll notice way more species, right? Species richness is something we will evaluate shortly. So I'm going to highlight my relative densities for each of these species. I'm going to control C to copy it, and right click, paste special, values, and transpose. I'm going to go to the dominance, control C, right click, paste special, values, transpose. And my frequency here, right click, paste special, values, transpose. And here we've got importance, and we will right click, paste special, values, and transpose, okay? And so again, these are going to be the graphs that you will have to evaluate for that quick assignment of 7 questions, okay? So I'm going to go over here to the comparisons. On the raw data, you should have what I pasted here. Not all the species show up in each of our sites, right? So, you know, the Mesic site doesn't have these species. The Xeric site doesn't have, you know, Thuox, doesn't seem to have Ace Pen, at least for this particular year that we went out and surveyed. I didn't want you guys to have to copy paste back and forth, so I just put it all in here. This is where we make our graphs, okay? But first things first, let's go back and let's quick fill out what our species richness is, right? This should be nice review for us, right? How many species do we have in the Mesic site? 1, 2, 3, 4, 5. And how many do we have in the Xeric site? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so right off the bat, you know one of these communities has greater species richness. Okay, and that might be important in the discussions that you kind of have later on as you're answering those questions. So let's make these graphs, because this is again how we're going to answer our questions. So this first area here is for the density, n divided by area, right? So I'm going to highlight, I'm going to go over to insert, and I'm going to insert a line graph, a bar graph, sorry. And remember, I don't like embedded titles. What I rather would like to see is you adding a chart element to the title, the vertical title being relative density, and adding that X title on the horizontal of site. Okay, so right off the bat, we're looking at density, numbers, number of individuals in your plots, and really obvious is Thuox is super dense in the Mesic site, right? Pine straw is, I wouldn't even say it's not even a co-dense species, right? Our wet site was totally dominated by that scale-like Remember when I showed you the picture of what the northern white cedar looks like? It's not a needle leaf conifer. It's kind of a scale or feather-like conifer. Very common in wet areas, and their bark peels. Okay, we have a stream in that mesic site, so that helps to explain some of that. When we go and we look at the density of the other, it's very even, right? We've got kind of even representation across the board in the dry site. And we're not really dominated, there's not really a huge dense representation of one particular species, right? They're all kind of almost equal in density. So that kind of suggests a bit more evenness. Okay, we'll move down here to dominance. So how big these things are, right? I bet you have a sense already based on what we've talked about, what we might see. So we're going to insert again a bar graph. Okay, and I'm going to get rid of that chart title. I'm going to go right over here and add the vertical relative dominance, and the horizontal will be site. Okay, now a little bit of a difference. Trends are kind of similar, but something that is obvious to me is that the mesic site, we have switched what is kind of, I'm going to put it in quotes here, the pine straw, the white pine, has taken over from that thuox, the cedar. Okay, so although thuox is still very dominant, meaning it's it takes up much more space, more area in the plots, the pine straw, and just how ginormous they are, the white pines, those big ship mast type pine trees, seems to be in the mesic site the most dominant in terms of size that they take up in that area. When we go and look at our xeric site, we have pine straw and pine rig, okay? And pine rig, I think, was our, maybe our pitch pine, and pine straw is the white pine. So we're dominated by pines. Again, think about that Silvix field guide, right? Silvix 1 was the softwood trees, so the conifers. If you went in and looked at what the needs were for pine rig, why do we see pine rig, cropping up as being dominant in that site? Or for that matter, all these other species that we never see in the wet site, why? Go look up in the hardwood Silvix 2. Go look up and see any one of these species and evaluate what their needs are. Maybe it speaks to some of the conditions at the site that would suggest why we have two different communities. But it is very clear that we have two very different tree communities in this forest, right? And now we'll move down here to frequency, which again gets at kind of the distribution of these trees. Again, we'll make our graph, go to insert, bar, get rid of this embedded title, and add in the vertical, which is relative frequency, and go over here and type in site. Okay, and you notice we've got what looks to be like co-frequency, right? The thuox and the pine straw is showing up in everybody's site similarly, and that might speak to the distribution of those species. So each one of these graphs is very important in describing the tree communities that you have at the site. One represents number of individuals, one represents the size that they take up in the area you surveyed, and the other one speaks to how often you see them across all the sites that were surveyed. So it gets at their distribution, okay? Again, that assignment, I'll pop it up a little bit later, has these three graphs in there and just has you interpret them very briefly with like a multiple choice kind of a thing, okay? So we're gonna go over to, let's just look at the biotics for a sec, okay? So I'm on the biotics tab right now. I looked at woodpeckers, the signs of deer. There were only some pellets, and we didn't see them at all. But if we had seen like deer browse, we could have noted that. Forest disease, we saw signs of forest disease. Two groups saw that in the xeric site, meaning that beech bark disease was, I think, what we were looking for, was common in that site. So we'd probably maybe see less beech trees back there. Or maybe there's just more of them and that's why we're seeing that. And then the woodpecker damage more in the mesic than the xeric. And then in terms of indicator species, things like mosses and ferns we talked about being like in wet areas. We see it more often in the mesic site, which makes sense, right? So these are all biotic things, living things that might help explain why some of those differences occurred. But the main thing that we actually can statistically test are the abiotics, at least for like what we collected or pseudo collected, right? I haven't heard you guys in a while. Somebody just say you're alive.
I'm alive.
Okay, yay. All right. So the first thing that we did was we collected soil, a soil core, and we brought it in and we added water and we put that soil probe in. And we've got values on the pH for the mesic site, which are about 6s, and then the xeric site, which were in the 5s. Now we want to see, we can graph this and get a trend, but we also want to be like, is that statistically different? Like, does that really matter? So what I'm going to call your attention to is our Moodle site. If we go all the way, hopefully you guys are seeing this, but all the way at the top where the writing and stats guides are, is this hyperlink here to a do-it-yourself stats analysis in Excel. You also could, like I said, go to the physics t-test, Google physics t-test, and run it that way. But this way, it's going to make the graph for us, okay? So I'm going to pull that Excel sheet up so you can see it. Okay, I'll try and scoot it out of the way. All right. Are you guys seeing two Excel sheets simultaneously?
Yep.
Good stuff. All right. So you've got two columns, and I guess I should say all across the bottom of this statistics module are a whole bunch of different other things you could do for statistics. And all you have to do is paste your data in, okay? So think about that for other classes that you're taking or research projects you're on. This might make life easier, okay? And it's available on our Moodle site. So I'm going to go over to the t-test. Remember, two groups being compared, some values being compared across these two groups. And so I'm going to look to paste in the mesic and paste in the xeric pH at this time. Okay, so we're doing a t-test to compare if the mesic and the xeric pHs were different. So I'm just going to paste them in. Okay, and first things first, let's take a look. I color coded. You can click on the bar. Make sure not both are highlighted, just one, and you can actually change the fill over here. I think with the paintbrush, you can change your colors and stuff, okay? But notice it made this for you. If you open it up kind of, I did this earlier, so it's got the labels in there. It's not gonna have the labels, you'll have to type them in. But you can do that very easily the way that we had before with the add the chart elements, okay? What I want to call your attention to is over here, right? We've got a t-test here of unequal variances. We have a t-test over here of equal variances. And remember, the things we want to look for are your, p-values, which, right here is the p-value we're looking for the equal variances, okay? So a p-value of 0.003, a degree of freedom of 6, and a t of 4.779, okay? If we did this in the statistics module online thing, we'd get those three things as well, but we wouldn't get this fancy graph, okay? So I also have pasted in this graph, as well as the one we're gonna make in a sec with moisture, and given you the p-values, but you just saw how that works, right? And knowing what we know about p-values, anything less than 0.05 means there was a statistical difference in whatever thing we were measuring across those two sites. So in this case, we kind of see it in the graph, right? The mesic has way higher pH than the xeric, but then we did a t-test, and the t-test gave us a p-value less than 0.05. So we're like, yes, it is statistically significantly different, okay? So that is important. That suggests that, yeah, pH could totally be explaining why we get these different tree communities. When this was done before, I don't have a densiometer data for you guys because it also was spring, so I didn't have any tree cover, leaves and stuff, so I was unable to kind of bring that in to show you, but we could have easily have gotten percent open or percent closed and done a comparison using a t-test to see what the p-value was and evaluate whether or not that was important in maybe distinguishing why we have these two different communities, okay? So now I'm just going to grab, instead of the pH data, what I've done is I've got the mesic, so this is the wet weight, and then this is the dry weight of the mesic. And then I did a subtraction of it to get the total, and then I converted it to a percent in case people wanted to report that in their PowerPoint, which you guys are not doing, but that's what we used to do. Did the same with the xeric. The soil from the xeric was weighed beforehand. We wanted it to be about 15 grams. Put it in the oven, got a dry weight on it, subtracted them, got this moisture value, moisture loss, and then did a percent. What we're going to compare are those moistures, the moisture loss. And so I'm going to paste that in up here. I'm going to delete these last two values there because we only had 3 groups that did this. And you'll notice, you know, obviously I have to change this header right here. It is soil moisture. I don't know if I spelled that right. Yep. But graphically, you know, we're looking at not much of a difference, right? From 5 to 6. So it looks, again, mesic seems to have more moisture than xeric, kind of the trend we saw with the pH, but is it statistically significant, that difference? And so we get, again, go over to your equal variance area, okay? And we look at our p-value is 0.639, our degree of freedom right here of 4, and our t of 0.506. So just looking at that p of 0.639, it's way above 0.05. So we cannot say there is a statistical difference with soil moisture, okay? And that is important to note. It looks like in terms of abiotics, we're leaning towards pH being really important in distinguishing these two communities, but probably not soil moisture. Although there was a difference, just not a statistical difference, okay? Any questions on that t-test? Okay, and I think I did mention earlier that you can do a t-test in Excel. It's a simple formula, equals t-test, open parentheses, and then you would highlight this, put a comma, highlight this, put a comma, put a 2 to say that you want a two-tailed, and then another comma and put a 2 for equal variance. Unequal variance, I think, was a 3, or maybe it was a 1, but it kind of prompts you through it. It gives you a little pop-up as you're building that formula, okay? Not that you need to, I just wanted to let you guys know that there is a formula that does that for you in Excel, okay? So again, I pasted this graph as well as the outputs of the t-test into the assignment just for you to kind of give me a quick, which one do you think is, you know, statistically given you, are you leaning towards, you know, one versus the other as being important for that community composition, okay? So jumping right back over here to our final thing to look at. You guys remember we talked about an app called SoilWeb on your phone, that when you open it up on your phone, you can click get location and it communicates with the satellites and gives you a soil series output. So a profile of your soil and tells you, you know, like what is it that you're standing on. For the mesic site, it was Colton, and for the xeric, it was pits and gravel, so a bunch of rocky things. And that may be important for drainage and soil type. Remember, as you go back to the Silvix book and try and explain why you saw these trees there versus those. Colton is a series. You can Google soil series and type in Colton, and it'll tell you some of what the soil type is like, and if moisture is common, if it drains well. But pits and gravel obviously is big kind of bouldery things. And if you had been out there towards the back, you probably would have seen the terrain is a little bit less even. When you put the soil core in, sometimes you hit rock like all the time, and there's only a few areas where you can get that soil. So that's pretty obvious. This Ruger Woods was a place that was farmed a long time ago, so that kind of makes sense that maybe this is where they dumped a lot of those rocks. Okay, that's what I wanted you guys to get out of the data analysis. I'm going to make the answer key down here. I'm going to go down so you can see it. I'll make that answer key live. Okay, not that you need to go back and refer to it, but maybe you do. Maybe you just want to have that for your files. And the assignment I have right here. I'm going to pull the assignment up just to kind of show you guys what I was thinking. Totally fine for you guys to work in a group. Just make sure that you submit both names or whoever is working on it together. What I'm looking for you to do is to go back to the data sheet and just populate the importance values into this table, okay? Anywhere that's shaded out as gray, there is no species that's represented in that locale for that. So just pop that importance value in for that particular species. Remember, importance, you'll have to go back to the tab for each of those specific sites. We didn't paste importance or graph importance in our 3 graphs that we made, okay? And so for questions 2 to 5, I want you to refer to the graphs that we just made, okay? These should look familiar to you. We made a relative density, a relative dominance, a relative frequency graph, and so you'll answer these questions. Which species comprises the greatest proportion of the mesic community in terms of average number of individual trees per unit area? So this in bold should either speak to you of density, dominance, or frequency, okay? And then look to your mesic, okay? So pick one of those graphs that's the numbers per area, look to the mesic, the blue, and pick the species that would represent that, okay? In terms of this next question, found most often, okay? So remember, found most often is a certain one of those 3 graphs that we made for the xeric site. Go back up here, find the appropriate graph, report the one that is maybe the highest, okay? And here, the greatest proportion of total area, okay, so size of that particular tree in both the mesic and xeric site. So that may suggest, that might point you in a direction that, or you know, suggest that in both of those sites, it ended up being the one that represented the most, okay? And then for part 5, it brings in, you know, the sylvic. So I want you to look at those graphs. I want you to think about the most important species, okay? You can go back to the sylvics 1 and 2 that's in Moodle. You might want to look at some of those rare species. You don't have to do a ton of them. Just pull a couple, investigate a couple, read through sylvics, and kind of explain why you think, you know, they were found in those sites, okay? And then questions 6 and 7, look at the soil pH, look at the soil, whoops, that should be soil moisture. I'll make that adjustment. Here's the T test results. So you get your p-values for your pH and for your moisture. And based on that, based on those soil characteristics, those abiotics, which of those traits that you evaluated had a statistical difference, okay? And then your final kind of step away based on this result, is this, you know, can you explain that answer? Is this what you sort of would have predicted to have found before you went in and evaluated all of this stuff, okay? Any questions? I'll have a Dropbox for that. I'll make that adjustment on that, the graph right here, I'll make that soil moisture, and I'll get that posted right away. But you should have access to the data right now, but I think you won't necessarily need to do any calculations on your own to do this analysis. Just wanting to get you guys thinking about, you know, you do these measurements out in the fields, then you come back and you do the analysis to kind of compare diversity and uniqueness and similarity across these communities, and then you want to dig deep and figure out, well, what could be causing that? Thinking about the abiotic and biotic factors that could be causing that. Any questions before I tune out? This will be due a week from today, okay? You can just drop that right into the Dropbox. And again, if you're working in a group, just make sure you've got everybody's name on it. Good?
Yep.
All right. Thank you, guys. Sorry for the, yet again, the fear and stress. I'll see you guys on what is today? I'll see you on Friday. Bye.
Bye.
Long.